Welcome to the Introduction to Debugging for the Cynthesizer Workbench, one of a series of basic training videos for the Workbench. In this video, I'll introduce the basics of debugging your SystemC code, how to launch the debugger, and explain the fundamental debugging controls. Once you understand this content, it should be pretty easy to start your own debugging sessions and master the rest of the debugger functionality. Now, the easiest way to look at the debugger is in the context of a concrete example that you can download and play with yourself. Cynthesizer Workbench comes with a set of pre-canned examples that you can download and work with to learn the product. Make sure you're in Welcome mode, select the Examples and Labs tab, and we're going to use this simple P2P example that is the first one in the list. Simply click on that and it will prompt you for a location for the files. Copy them down, and we're ready to go. Now, the file that we're going to be looking at today is in dut.cc. Double-click that to open it. This is a very trivial example that takes a single input, multiplies it by 7, and produces an output, and outputs that on a port. The first thing we should do here is, in looking at this code, figure out where we would like to break. And we'll set a breakpoint on this line of code that outputs the value. We go just to the left of the number and click, and it will place a breakpoint there. That round circle indicates that a breakpoint is currently there and set. In order to run the simulation and debug it, we need to first select which simulation configuration we're going to debug. We're going to select the B configuration, which is a behavioral simulation. Now, there are two ways to launch the debugger. The first is to right-click on the name of the simulation configuration and select Debug. Or we can simply select it and press the debug button in the Actions button pane. Let's go ahead and do that. It will automatically compile our design, which has yet to be compiled. And when that's complete, we'll be ready to go and debug. Okay, so the build is complete and we're ready to debug. As you can see, it's a little crowded with the various different panes for the debugger. So we're going to go ahead and close the sidebar in order to give ourselves a little more real estate. We'll click on the Hide Sidebar button in the bottom left-hand corner. Here we see we have four main panes. The left top pane is the source code pane. That includes the list of breakpoints and where we're currently broken, indicated by the yellow arrow. The top right pane is a list of variables in the current scope and their various values. If the value is a complex structure, we can pop that open and see the internals and look at the values of those member variables. The bottom left pane is the stack trace pane, and we'll look at that in more detail in a moment. And the bottom right pane is the list of current breakpoints that are set in the design. So first off, let's take a look at some of the basic controls. Here we have the Continue button, which means continue to the next breakpoint. Next is the Stop button, which will stop debugging and kill the current process, the current simulation process. Next is the Step Over button, which allows us to go to the next line of code but step over any functions that would be called in the current line if they exist. The next is the Step Into button, which will step into functions as we execute. And the next is the Step Out Of function, which will basically step out of the current function if we're in one. So let's go ahead and set a breakpoint down here inside a function. Press the Continue button, and you can now see that we have broken inside the function f. This is at line 30 in dut.cc, and you can see this was called from line 20 in dut.cc by looking at the stack trace. Now we can go to any position in the stack trace simply by double-clicking on a line of code, and the whole context will change. So we'll see the variables that are in scope at that point and their values. We can go back to the other as well. Remove this breakpoint. Continue. And you can see that as we iterate, the values in the value trace pane change. Now, modifications have been made to the tool in order to display more useful values for complex classes that are very common in SystemC. So you can note that both inval and outval are of type SCUint8. That's a complex class in SystemC and would normally have a very complicated structure, and it would be somewhat difficult to see the values that are held in that variable. We've modified this to show you those values in a sensible form here in decimal and hexadecimal that makes sense to you when you're debugging. Now that extends to more complex classes, for example, the CynthWB fixed class. So let's go take a look at that, and I'll add a new variable of that type and we can see how that looks. First, we stop the debugger, go back to edit mode, and we will add some code for a fixed point value. Add the header file for CynthWB fixed, define a new variable, assign it a value, and we're ready to go. So all we need to do is go back down here and hit debug again. It will automatically build that. And it will run to our first breakpoint. Now you can see in the variable trace pane that Fred now exists over there, and we can continue a few times and we'll see it changing values, and it changes values to something that's sensible to me. I can actually see it in both its real form, 4.7598 for example, and also the two hexadecimal components that make up the fixed point value. This is a very, very useful extension to the basic functionality of GDB. Now this is an introductory video, but there are many, many more features of the debugger that I'm not going to go into. If you want to explore by yourself, simply right-click in some of the panes and you'll be able to see some of the complex features that are available, including things like changing memory locations, adding database breakpoints, etc., etc. Each different pane will have a different set of menus that control how it functions and what you can visualize during the debugging process. That concludes our demo on Introduction to Debugging. It's worth noting that I've only scratched the surface in this video, but it should serve as a means to get you started on your own. Please review the other videos in the series to learn all the common tricks for getting up to speed as quickly as possible.